Okay, in this section we're going to talk about tessellation and displacement, which Redshift is surprisingly good at. We can get to the tessellation and displacement options by adding a Redshift object tag to our object and flip over to the geometry tab. We've got both tessellation and displacement, enable for both. Let's go ahead and start with tessellation. So we've got an enable disable, and we have subdivision rule. I'm just going to jump into my shader real quick. I just have a very simple diffuse, spec, and displacement setup, and we'll go over the displacement node in the shaders chapter. So I'm just going to plug in a wireframe node so we can see what we're doing in here, and disable my depth of field. So let's take a look at subdivision rule. There are two options, Cat-Clark and loop, or Cat-Clark only. Cat-Clark subdivision is designed for quads, and loop subdivision is designed for tries. So Redshift gives us the option to use subdivision for both quads and tries or quads only. So let's dig in for just a second and see what that means. So I have both a quad and a try here. And if I have the Cat-Clark and loop option enabled, we can expect to see that for the quad, we're going to subdivide like this. And for the try, it's going to split each edge like this. So in both cases, by subdividing, we're going to get 4 more polygons. So if I hit enable, you'll see we have our original triangle and our quad. So this is certainly the most efficient option to choose because Redshift is going to look at your mesh, say, hey, you're a quad, I'm going to divide you with Cat-Clark, and hey, you're a try, I'm going to divide you using loop. And in both instances, we get 4 more polygons. So in cases when you're using software that doesn't support loop subdivision, there's also the Cat-Clark only option, and it's going to do things a little differently. So for each try, it's going to first split each one into 4 quads, like so. And then each quad will get 2 faces, and we have our subdivided try. Now it's important to note it's not going to change the profile of your geometry. It's just changing how it subdivides it. Okay, so back to our pile of rocks. Let's move on to screen space adaptive subdivision. So screen space adaptive subdivision is a pretty lazy guy. He's only gonna put as many subdivisions on the geo as he is required. And the requirement is the closer you are to the camera, and the requirement is if you're a polygon and you are longer than 4 pixels in length, then give me another subdivision. So naturally what happens is as geometry gets closer to the camera, the geo takes up more pixels. And our requirement here is no larger than 4 pixels. So it's going to subdivide these guys that are closer to the camera. However, these guys that are farther away do not need to be subdivided because they are under 4 pixels in width. So more or less, we're going to be able to make out exactly where this rule is having an effect. You can see kind of right along this line here, the geometry in front of this line looks a little bit more dense than the geometry behind this line. And as this geo gets further and further away from the camera, the real estate that it takes up in the image plane gets smaller and smaller until it's under 4 pixels, and then we don't need to subdivide it anymore. So we can see there's another line back here, and so on and so forth. Now this is really useful because it allows us to do a lot less subdivision than we would otherwise. If I subdivided these guys back here by the same amount that I subdivided these guys here, it'd be a lot more space on our GPU, and it'd take a lot longer to process. Now there is a safeguard, and that is the maximum subdivision amount. And this guy basically says, obey the minimum edge length rule. However, you can't go over this maximum subdivision amount. And while we're talking about subdivision amount, let's also talk about the out of frustum tessellation factor. So this dude is basically saying, if I can't see you, I don't need to subdivide you. Now one important note about this is this only works on full objects. So in the case of our big landscape plane here, it's still going to calculate all of the subdivisions outside of the image plane. However, if there is an object off frame to the right, it's not going to subdivide that object, or rather it will subdivide the object less based off of this number. So the last thing we're going to talk about with tessellation is if we uncheck screen space adaptive. So with screen space adaptive unchecked, the new rule for minimum edge length is based in world space. So right now, hey, if you're over 4 centimeters in width, you get a subdivision. And right now, every polyface we have in here is over 4. And right now, every polyface that we have is under 4 centimeters in length. So we have no subdivision happening. But you'll see if I knock this guy down to 3, our subdivisions start to kick in because all of the polyphases are violating our rule. So lastly, I want to walk back to smooth subdivision and UV smoothing. And for this, we're going to look at a picture of a UV rock. So right now I have smooth subdivision disabled, which means we are still subdividing, but we're not doing any kind of smoothing. Like these little sharp edges are still exactly there. We've just added more polygons. If I enable smooth subdivision, it's going to smooth those guys out. You can also see it's kind of bonked up our image texture here. And here's where UV smoothing comes into play. UV smoothing is going to go, hey, remember how we just smoothed over those sharp edges? Let's do the same for our UVs. So now as you can see, our image is returned to a undistorted state. Now there is a second option under UV smoothing called internal edges. Now all edges just smooths everything. However, in some models, especially if you need your UV edges to align specifically to quads, this smoothing might jank that up a bit. So internal edges says, hey, smooth everything except for my UV boundary. Now we happen to have a UV boundary right down the middle of our rock here, so I'm just going to take a quick picture viewer of this guy. Holy crap. There we go. And I'm now going to enable internal edges and compare the results. So if I flip between the two images, you can see that we're just saying, hey, keep the very boundary edges the same. Don't smooth those guys. So next we're going to move on to displacement. And the way we get displacement working is, well, first we enable it. And secondly, we need to have a displacement node with a displacement texture wired into it, wired into the displacement output of our redshift material. We're going to go over that later, so for now, don't worry about it. So let's talk about maximum displacement and displacement scale at the same time. And I'm just going to flip to a basic shader. Actually, let's talk about enable auto bump mapping first. So any displacement details that we can't get into our geometry through the displacement, auto bump mapping is going to chuck into the bump map. So if I really want to see what's going on with my displacement, I need to uncheck that guy. Okay, back to max displacement and displacement scale. So max displacement is going to say, cool, you got displacement, I like it, don't go any farther than this. So right now I'm set to 1. If I set this up to 10, we're not going to see an effect yet. All we've done is raise the limit of where our displacement can hit. I need to start walking up displacement scale before I start hitting this max displacement wall. So let's kick our displacement scale up to 5, not hitting the wall. If I kick my displacement scale up to 10, we're probably not still going to see the wall yet, because even if my displacement map goes to full white, that full white is going to represent 10. So right now we're just going up to that limit. So in order to see that, let's go ahead and walk the max displacement down to 5, down to 1, and you can see we're just clipping off our displacement. Now, the last part of this section, is that I just want to urge you to make sure to disable that auto bump mapping when you go to tweak your displacement, because when it's on, it's really hard to tell what our displacement really is.